Welcome and thank you for joining this EDI or Everly Design Incorporated webinar. I am your host, Dr. Bill Sowell, Vice President of Business Development for EDI and Reno A&E. Today's topic is EyeSight, or Intelligent Cabinet Interface to Traffic Equipment. We will also provide you with an update on our lead product in the EyeSight product suite, the Data Aggregator, or DA-300, which is a device designed and manufactured by EDI that facilitates the collection of real-time traffic data, enabling you to immediately convert any isolated intersection into a connected permanent traffic count station. The data we can provide meets all of the requirements for automated traffic signal performance measures, or ATS-PM. EDI is headquartered in Phoenix, Arizona, and is a leading manufacturer of electronic safety monitoring and detection products for the traffic, access control and parking, and railway market sectors. Our products include intersection conflict monitors, inductive loop detectors, power supplies, flashers, load switches, and other mission-critical infrastructure and control components. Our devices allow transportation professionals to integrate, automate, and optimize traffic flow in intersections, roadways, and parking and access locations easily, efficiently, and safely. Just like every other concerned transportation professional, we seek to move people and goods more efficiently and safely through the surface transportation network. We are the folks that manufacture a majority of the peripherals that reside in the traffic cabinet, and it is our job to provide safety monitoring in that intersection, making sure that you and the members of your family make it to work or school and back home safely every day. EDI designs and manufactures more than 850 different products, and it's estimated that we have more than 4 million active devices operational in traffic cabinets around the world, including North America, South America, the Caribbean, Asia, Oceania, and the Middle East. Those 4 million devices perform more than 2 billion error-free transactions every 24 hours. Our mission is to enhance motorist and pedestrian safety wherever possible. Every employee of EDI and Reno A&E understands and focuses upon 5 core values for our partners that have contributed to our 37 years of success as your trusted partner. We provide just-in-time supply that minimizes your need to carry a large product inventory. We provide high reliability of products that are mission critical for intersections and railway monitoring to ensure that equipment inside the traffic cabinet cannot cause an unsafe condition. Our team members are empowered to provide extreme service for our partners. Whatever their priorities may be, those instantly become our priorities. We believe in a fair pricing policy for our partners, ensuring that they receive quality and reliable products at a competitive price. And lastly, we deliver both standard and customized products and solutions to our partners, which may include unique functionality for a specialized application or perhaps private labeling of products that match those your company provides. EyeSight stands for Intelligent Cabinet Interface to Traffic Equipment. The DA, or Data Aggregator, is a hardware platform that can interface to any EyeSight-ready provider of cloud-based traffic data analytics or provider of traffic planning solutions. The Data Aggregator is a hardware platform that is data and communications rich that can be applied to any application that requires remote communications and retrieval of any type of data, not just traffic data, but perhaps road weather sensor data, agricultural data, or any data that is time sensitive to be useful and actionable. The DA-300 can easily transform any Type 170 or 2070, NEMA, TS1, TS2, ITS cabinet, or ATC cabinet into a permanent traffic count station with cellular or Ethernet-based connectivity to the cloud or a locally based server. The DA-300 is traffic cabinet, traffic controller, and detection technology agnostic. We can retrieve real-time traffic and intersection status data from the traffic cabinet, the traffic controller, or IP-enabled detectors, MMUs or CMUs. We currently have 2 partners for whom we provide traffic data that are EyeSight ready. The DA-300 has a simple interface to detectors through an SDLC port, Ethernet port, or analog input up to 32 channels of detection. For isolated non-interconnected intersections, the DA-300 can provide a GPS-based sync pulse to the controller to ensure proper intersection coordination, striving for optimal green band progression. Interface with any controller with an SDLC port ensures that installation and integration of the DA-300 into either a NEMA shelf mount or 19-inch EIA rack configured cabinet should take an average of 15 to 20 minutes in the field. The interface to traffic cabinets of all types has already been encountered in the field, and we provide several different types of wiring harnesses to make the cabinet and device interfaces as simple as possible. Being cabinet and controller agnostic is always helpful to perform a cabinet inventory before placing an order, so we know in advance what type of cabinet, controller, detection devices, and MMU or CMU the DA-300 will be interfacing. The DA-300 includes an environmentally hardened cellular modem that is both PTCRB and carrier certified that meets or exceeds the NEMA temperature range, as well as our field testing here in Phoenix during our sweltering summer season. We provide a cellular module that is specific to the type of cellular data plan your agency may already have with T-Mobile, AT&T, Verizon, or Rogers. We can also provide 3G, 4G, LTE cellular modules that are compatible with international cellular carriers, and those outside of the U.S. should indicate your preferred cellular data carrier at the time of order placement. The average monthly cost of a negotiated cellular data plan, depending upon the desired carrier, is approximately $15 per month for a standard data set. Monthly cost for data sent each second could be higher. However, our data compression capabilities have been very successful at keeping data costs to a minimum. We offer a variety of annual cellular data packages that have been negotiated at a significant discount and ensures that you won't be paying a huge surprise cellular bill monthly. Your cost to connect to that remote intersection is minimal, and you can receive whatever data you may need for such things as automated traffic signal performance measures, or ATSPM. The DA-300, again, is a hardware platform that is detection technology agnostic, that can easily interface with communications-enabled detectors and devices equipped with SDLC or Ethernet IP addressability. This includes inductive loops, video detection, magnetometers, laser detection, thermal and IR detection, radar and microwave-based detection, piezoelectric sensors, and travel time sensors using either Wi-Fi, which is our preferred standard, or Bluetooth can be provided as an option. Travel time and origin destination information comes from an EyeSight-ready data analytics partner. This is a DA-300 mind map that illustrates to what the hardware platform can be connected. This can include the traffic cabinet, where real-time data can be provided on the status of the battery backup system, cabinet fan or heater status, cabinet ambient temperature, whether a cabinet door is open or closed, if the intersection is in flash or fail status, and detector faults. This allows traffic signal supervisors to be proactive in dispatching crews to resolve field anomalies and identify cabinet issues before they become serious problems. Additionally, the DA-300 can provide status on cabinet main power and primary cabinet communications, as the DA-300 has an internal battery backup that can initiate an alarm using the cellular modem as a communications rollover to provide communications redundancy where necessary. The wealth of data sources, as you can see, is significant, and we would be pleased to show this to you in person during a detailed DA-300 and EyeSight G2, our cloud-based server interface demonstration. Pictured is a standard DA-300 solution diagram. Beginning in the lower left of the slide is the DA-300, which is shelf or rack mounted into the traffic cabinet, where it could be connected via Ethernet to a managed switch in the cabinet, or it may use its internal cellular modem to communicate and transmit the data received to a cloud-based server for data analytics and reporting. The DA-300 can provide a GPS-based sync pulse for remote intersections to optimize traffic signal coordination. The DA-300 may be connected to a traffic controller via Ethernet or SDLC in a NEMA TS2 cabinet. Connectivity to detectors through Ethernet, SDLC, RS-232 or RS-485 detectors, which are communications enabled. When necessary, we will work with detection solution providers to develop an API that is specific to their detection device. We are as concerned about cybersecurity as you are. The DA-300 communications uses a 2048-bit encryption to ensure that device and network security are maintained at all times. The DA-300 value proposition for the city traffic engineer or traffic signal supervisor could be the generation of real-time traffic data, remote traffic cabinet connectivity via Cellular, real-time detector data with granularity that can be detection zone specific, GPS-based time sync pulse for isolated intersections, travel time analytics, origin destination data, and alarms sent via SMS or email for critical intersection anomalies such as flash, failure, loss of power, loss of primary communications, battery backup status, and other cabinet health conditions. The DA-300 has an IP-based pass-through via UDP or TCP/IP that can transmit data to the cloud for analysis or reference. This could include, but be not limited to, detector data, still images, or compressed video clips. Through the services of one of our trusted EyeSight Ready solution partners, the DA-300 can facilitate real-time traffic data needed for annual traffic count studies at each intersection, automated traffic signal performance measures data, the Purdue coordination diagram, and Q-length using a specialized detection zone and detection technology. The needs of the traffic planner or traffic consultant can be met with the deployment of a network of DA-300 units in the traffic cabinet, which could provide travel time analytics by route or segment, origin destination data, controller data, MMU data, detector data and status, the Purdue coordination diagram, and Q-length can also be provided with specialized configurations. The FHWA EDC4 Automated Traffic Signal Performance Measures team recently provided this great chart which simplifies the identification of what performance measures data a traffic agency needs based upon their goals and unique traffic conditions. For safety, an agency should collect data on yellow and red actuations, arrivals on red, and pedestrian and bicycle delay. To ensure the roadway network is in a good state of repair, data on detector failures, preemption details, communications failures, and intersection and traffic cabinet alarms should be collected and analyzed. To optimize mobility, data from the Purdue coordination diagram, Split failures, pedestrian, bicycle, and vehicle delays, queue length, and split monitor information should be collected and analyzed. To ensure quality customer service, data on travel time and turning movement counts are deemed essential. Regional FHWA seminars on EDC4 or everyday counts are being held regionally, and you are encouraged to attend. You can learn more on the internet at the web address noted on this slide. Through the wonderful efforts of Professor Darcy Bullock at Purdue University and many others, the Purdue Coordination Diagram provides a time-space diagram on arrivals on red, amber, and green, and allows traffic engineers to visually see how their traffic signal timing can be optimized to reduce delays and travel time. The DA-300 is a hardware platform that interfaces with any EyeSight-ready traffic data analytics provider, interfaces with any type 170, 2070, NEMA TS1, TS2, ITS, or ATC traffic cabinet. The DA-300 connects via SDLC port and receives all NEMA TS2 SDLC messages. The device connects via Ethernet to an Ethernet-enabled traffic controller, or MMU, and can connect via serial port to gather information from the MMU via ECCOM or Raycom software. The DA-300 is ideal for isolated intersections not connected to a central ATMS system, as the device has an environmentally hardened cellular modem for data transmission to a cloud-based server, where data analytics are performed. A traffic management agency may not have the budget to purchase new central ATMS systems or new traffic cabinets or controllers. The DA-300 can interface with legacy controllers and cabinets and provide a wealth of traffic data that can also be provided by many new state-of-the-art traffic controllers and central systems. Widespread deployment of the DA-300 can also provide a wealth of real-time data to a central ATMS system, augmenting the existing stream of data coming from the traffic controller. Additional detector granularity, backup communications, and alarms for cabinet power outages, intersections in a flash state are also readily available. The DA-300 hardware platform can provide the necessary data to a data analytics provider to furnish Wi-Fi-based travel time information. Bluetooth can also be provided as a special option. We provide a 5-band antenna which can receive GSM, GPRS, LTE, Wi-Fi, Bluetooth, DSRC, and GPS radio signals. Any of these can be analyzed as sensor data. We work closely with various detection technology providers to develop special APIs that interface with their unique detector communications protocols, enabling very detailed detector data retrieval and reporting. We are proud to be working with two EyeSight-ready traffic data analytics providers, and they take our parsed traffic data from the EyeSight DA-300 hardware platform and provide a unique user interface and a myriad of performance measures and data analytics that will meet your traffic data needs. We have been working for more than a year with a Cyclica based in Denver, Colorado, and they have personnel located throughout the U.S. to provide local support and service in traffic data analytics. The Traffic Group is a well-established traffic data analytics partner with multiple U.S. office locations that is the market leader in traffic count studies and specialized traffic planning analysis and solutions. Please contact either or both of these wonderful partners to learn more about their unique market-leading traffic data solutions. This completes my section of the webinar, and I kindly thank you for your time and consideration. Section 2 of the webinar begins now. My colleague, Tim McCall, Technical Product Manager for the DA-300, will now demonstrate the hardware platform functionality using the EyeSight G2 cloud-based user interface and configuration tools.
Hello and welcome. This is Tim McCall, Technical Product Manager for the EyeSight DA-300 product line. We welcome you to our online webinar demonstration of the EyeSight G2 website, which is used to access the extensive data analytics and the traffic cabinet's health information capabilities provided by the implementation of the DA-300 system hardware into your agency's traffic control cabinets. Please keep in mind that this webinar is intended only as a short introduction to the extensive capabilities of the EyeSight DA-300's integrated hardware and software platform. We will not be covering many of the advanced features and capabilities of the EyeSight DA-300 system due to the time constraints of this webinar format. We would be very happy to arrange to work with you to schedule an on-site live demonstration and training in the capabilities of the data aggregation system to any interested traffic agency's staff. Please contact us directly to make those arrangements. The first screen that you will see when opening the G2 website, located at g2.acyclica.com and hosted by our strategic data analytics partner, Acyclica, is the login screen. After logging in, you will see a number of toolbars and icons, each focused on different aspects of the service and information capabilities of the EyeSight DA-300 system. In the upper left corner, you will see a search bar where you are able to enter a DA-300 serial number or the specific assigned name of the device. You will then see a drop-down menu of selections that gets narrowed down as you add more characters or digits into the search bar. Here you can see me select the traffic control cabinet located at the intersection of West Fry Road and North Price Road in Chandler, Arizona. Once you have selected and focused on the specific device you are monitoring, there are a number of data points you are able to review. After finding the relevant data you desire, multiple report formats and file export capabilities exist to assist you in creating comprehensive traffic analysis reports. In the upper right-hand corner, you will see a drop-down menu labeled Map Filters. In this menu, you can select devices, VSO devices, and cabinets. It is important to differentiate between cabinets and devices in the G2 interface. Devices are the portion of the system associated with travel time calculations and their associated analytics, and the cabinets are the selection for viewing and reviewing the specific information related to the location and cabinet in which the data aggregation unit is installed. In the future, there will be one drop pin for both the device and cabinet, and the information associated with each will become integrated into a single display to increase our customers' ease of use and facilitate a more intuitive graphical user interface. In this example, I will deselect devices and select cabinets. Now that I have selected cabinets, let me minimize the map markers drop-down menu and then click on the left toolbar button labeled Current State, which is down towards the bottom of the listings. I will then click on the double arrows on the right side of the toolbar for this window to maximize the view, and I am then able to see the current phase state of the intersection signals being graphically displayed. If I refresh this window after a short interval, we will see a signal state change in the graphical signal head indications displayed in this window. Along the left side of the window, we will see a number of lines of information related to the status of the cabinet we have selected. These include fan and the cabinet's heater status if one is installed, the cabinet door and whether it is opened or closed, and whether FlashSense and stop time are active or not. Pay close attention to the door voltage, flash sense, and manual control enable voltage values assigned to these parameters in your DA-300, as it is not a uniform voltage value across our industry's traffic cabinet manufacturers. Each of these monitored voltage values is easily adjusted in the DA-300 cabinet setup configuration menu screen. The battery backup system status messages, if one is installed and connected, is also displayed. If the cabinet has been placed in stop time via manual control enable, that information will also be displayed. The cabinet AC line voltage and the DC voltage value internal to the device are also displayed. The internal 5-hour battery backup's current battery value is displayed, as well as the internal temperature of the cabinet. Keep in mind that the DA-300 is available in both DC and AC form factors and can function across the full voltage spectrum to international standards with no modifications needed other than the form factor of the power plug being used for interconnection. We also see the standby battery's internal voltage displayed. The standby battery provides up to 5 hours of power to the DA-300 in the event of a power loss of the main voltage power supply. This capability provides the ability to differentiate when the signal has gone dark if there is no available battery backup system at the location. The ability to generate a statistical voltage log is currently under development. This will assist greatly in determining those locations where sporadic voltage outages are occurring and provide documentation to assist in working with the local power company in resolving intermittent power outage issues. The internal cabinet temperature is then displayed and is also logged to allow statistical calculations to be conducted on historical temperature ranges experienced inside the traffic control cabinet and enclosure. When the temperature is above a set value and the fan does not come on, the system can generate an alarm via text, email, or pop-up window. Alarms can also be generated and transmitted under other conditions, such as if the temperature is below a set value and the heater does not come on, if both the fan and the heater are on at the same time, or if the temperature is in a range where either the fan or heater are operating and they should not be. In addition to these remote alarm indication capabilities, local alarms can be generated via contact output to drive exterior visible lighting indications or other sensor outputs on an as-needed basis. We also see the number of GPS satellites visible to the installed DA-300, which are used to auto-locate the system on installation, and also to provide a continuously updated real-time clock, which is used to timestamp all collected data and information to within 1/10 of a second of its occurrence. The GPS signal can also be utilized to provide an actuated relay output, which can be utilized by a traffic signal controller to provide real-time clock synchronization up to twice per day. The next thing I would like to talk about is the selectable time and date windows located along the top toolbar slightly right of center. I am going to select a 3-hour window, start time in the left drop-down window, and end time in the right drop-down window. I am selecting the time period from 7 a.m. to 10 a.m. to show the morning peak busy period. As you can see, this selection generates a line graph showing the associated counts volume of each associated phase at the intersection. I will first maximize the window to increase visibility, and then direct your attention to the radio button selections along the left side of the window, where you can select and deselect whichever phases contain the information you desire for review. You can also select in the upper right corner of the display window the selection for the associated tabular data for the specified time and date range of the intersection you are viewing. Scrolling to the bottom of this window will reveal a radio button that allows you to download the associated CSV file for importation into any other program you may want to utilize to analyze the data and generate reports in a secondary format to the ones provided on the website interface. This same information is also available via an API call to the cloud-based web servers for those people that desire the bulk, raw data be imported into a secondary application for additional processing. We would be happy to discuss this capability further and arrange for a live demonstration utilizing real-time traffic data at the location of your choosing. Looking at the upper left corner of this window, you will see a radio button labeled Add to Report. Clicking on this button will add this information to the reports area of the G2 interface. Multiple reports can be archived into this area until needed for export at the end of the data collection session. There are also extensive auto report generation capabilities available utilizing widgets and other tools. These capabilities are covered in depth during our comprehensive EyeSight DA-300 training sessions. I will now exit out of this window and click on the upper toolbar, clicking First View and then Reports, where you can now see the graphical representation of the counts data we just created using the 3-hour AM selection. You can right-click on the image and rename it and save it as needed. Exiting from this menu will take us back to the main G2 interface menu. From here, I will now select the RYG plus movement selection on the left side toolbar. It is worth noting that these same selections can also be made using the drop-down menu along the top of the page labeled Analytics, then Cabinet Tools. Multiple navigation routes in the interface streamline navigation and provide multiple opportunities to quickly arrive at the screen you desire. I again will maximize the window to provide good visibility and look at the signalized intersections associated phase information. You can see here the line graphs below the phase information representing the traffic counts and the associated phase states of the signal. This information is available as an integrated data set to provide a graphical display containing the information seen in a Purdue coordination diagram. A variety of display configurations will be available, and we look forward to working with agencies and academia to determine what graphical display and representation will deliver the most value and information to our installed customer base. Phases that do not contain detection-enabled technology will only log the status of the phase information and are unable to provide count data. Pedestrian phases would not typically be configured to provide count information, but there are solutions for that application, as well as the ability for the DA-300 to be wired into the pedestrian push buttons to provide a count of the number of pedestrian push button activations. Closing this window, we will now look at the health information related to this cabinet by clicking on the left toolbar. This will give us a historical statistical display of the cabinet's internal temperature and voltage values. I will now select map markers on the upper toolbar again and deselect cabinets and select devices. You can see the icons change when selecting devices. I will then select the same location and direct your attention to the left toolbar, where you will see a different toolbar has appeared that is related to the data analytics capabilities of the system when multiple units are deployed for route and travel time analysis. The first thing I will select is an associated route with this device. Selecting the associated route then shows me all the devices in the associated route with the icons in a different color than the non-associated route devices. Looking at the toolbar along the left-hand side, we will see a number of selections. Alongside each selection, you will note a small question mark. Hovering over the question mark will reveal additional information related to the selected data analytics metric and the available reports. As you can see, the available reports are comprehensive and outside the time constraints of this short demonstration. For the purposes of this webinar, I will limit my discussion and again say that we are happy to provide a comprehensive on-site demonstration and training session for any interested parties or agencies. We can select our time range and then click on the travel time selection, which will generate a report for review. I will again maximize the window. As you can see here, there are 3 lines across this graph representing the first time the unique Wi-Fi MAC address was detected, the last time the MAC address was detected, and the strongest signal strength of the MAC address as it transited the intersection. Various data resolutions are available by selecting the desired interval from the drop-down menu. You can also drill down by selecting a more granular time of day selection by clicking and dragging with your mouse, and also maximize the display by doing the same on the travel time of the graph data. I can click in the upper left side of the window to add this report as a widget and recall the report in the future. Clicking on the plus sign radio button along the right side of the G2 display will show you the saved widgets available for report generation. This concludes the EyeSight G2 demonstration of this webinar. Thank you for your participation with us today. Please be aware that we will be releasing additional short video demonstration segments providing comprehensive instruction in specific areas of the EyeSight G2 user interface in the future. Keep an eye on our website where we will announce the release of these instructional videos. We look forward to working closely with you all as we move forward with the nationwide implementation of the EyeSight data aggregation system. Thank you and have a great day.